we going to go right to the group meeting quiz thing, or do you want to go over the homework first, or the preparation stuff?
Let's see.
We're already 20 minutes into it, so maybe we should just start.
Yeah.
I'm
we
down
can
with that.
Okay.
Ugh, I gotta go let my dog out. Hold on.
Okay.
All right.
Now the dog's gonna want right back in. Watch.
I know. Although it is sunny today, he likes to sunbathe.
Oh, nice.
Yeah, he's a funny dog. Okay. Number 3. The symbol for the true population proportion is p hat.
Yes.
Yep.
And it's not the little squiggly weird line. It's the one that looks.
What's funny is I was actually thinking about it today or yesterday, and it's like now I know why they call it pea hat. Is the pea's got a little hat?
Yes, it does.
You're like, what are we gonna call this?
Yeah. Okay, so I'll get number 4. For questions 4 and 5, suppose n equals 100, p equals 0.25, and p hat equals 0.10. The requirements for constructing a confidence interval satisfied. So for it to be satisfied, it has to be NP is over 100, or sorry, over 10. I need to get my.
So we have to figure out both of them.
Yeah, we need to figure out both of them. So 100 times 0.25, that's 25. So that satisfies that part. And then it's P, which is, where is it? Is it P hat or P? P hat, right? P hat parentheses 1 minus P hat.
Yeah, it's P hat.
Okay.
So it's n times and then parentheses 1 minus P hat.
Okay.
Yeah.
So 1 minus 0.10, which is 0.9, times P hat, or n.
Wait. So you're doing the second equation?
Yeah. What's the second equation?
So it's n times, and then it's the 1 minus P hat in the parentheses.
Okay.
So yeah, it'd be n times whatever you got from doing the parentheses part.
Okay. Yeah. They both satisfy it.
Cool.
Is everyone on board?
Yep.
True. All right, so number 5, the requirements for concluding a hypothesis test are satisfied. So that one, let's see here. Hypothesis test is a little different, I thought.
Yeah. Was that in 16 or 17 chapter?
I think it was in 17.
I'm pretty sure it was in 17.
Let's see. Hypothesis.
I think that one has to do with the P.
Is that where instead of doing P hat, you do it for just P?
P, yep.
Okay.
Yep.
So it's the same thing, only you use p instead of p hat?
Yeah.
Yeah, that makes sense because the hypothesis test would be for the whole test, and P is the whole population.
Okay. So P is 25 at 0.25. So then We got n, which is the sample, so 100 times 0.25, right?
Yeah.
So that gives me 25, so that's above 10. And then we have 100, and we got 1 minus 2.5. That's 75, so they're both greater than 10. So yeah,
Okay.
I'd say true.
Okay. Amy,
Great.
you're up.
Okay. A study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty. Use this information for questions 6 through 8. Find p hat, point estimate of the population of first-degree murder defendants who are found guilty in this state.
So that would be x over n, right?
Right.
Yeah. Define p hat.
So wouldn't it be 45 over 60?
Yeah.
Yeah.
So 45 divided by 60 is, let's see here. .75.
That's what I
Yep.
got.
Yep.
So
Should we do 750 since it says to round to the 3 decimals?
yeah, that's what I do. I just add a 0.
Yes.
Okay.
All
Okay.
right.
I guess I'll go next. Create a 95% confidence interval for the true proportion of first-degree murder trials in this state. There, the verdict is guilty. So, that's a long formula.
So create a 95 true for true proportion first degree.
Where's that at?
So then,
So it would be,
It's that where we use the critical value, the Z star,
yeah.
yeah,
and
So
the
I'm
95, that's 1.96, so that's the
yeah.
Z star.
So Z star is 196, and then let's see
I
here.
think it's done.
So then is that where we do the n? Or we're trying to find n, right? Or wait, we're trying to find
Yeah.
what?
We're trying to find the confidence interval. So that would be if you want to look at my screen, this formula right here.
Okay.
Okay.
P hat minus Z star square root, all that mess,
That is a mess.
and then repeat it with the plus.
Oh yeah, this is where we can use that thing for it.
Yeah. And I talked to him, and he said we can use it on the test.
Oh, yeah.
I'm gonna find that email. Excuse me. I ate lunch in a hurry when I got home.
95% confidence interval.
Categorical.
Oh, darn it. I might have to actually use the formula.
Why?
I don't know what the null hypothesis is.
Oh, we're not doing a hypothesis test, so we just leave that blank.
0
You just leave it what it's at.
at 0.52?
Oh, mine's at 0.70.
Oh.
Yeah, we said,
Does that
yeah,
change
because
it?
when you're doing a hypothesis test, then you can change that part. But really, you're just focusing on the first 3 on that side.
Oh yeah, and plus it doesn't change it. Like I'm changing it right now to different numbers, and the confidence interval doesn't change.
So
Oh, perfect. And
we're using the previous data, right, for this question,
yeah,
for the p
Yeah.
hat. Okay. So the
is
p.
anybody actually doing the actual formula?
I
No.
didn't.
You are, Amy?
Yeah.
Okay. Good. Are you almost done with it?
Yeah. I got 0.640432667. So if you round that 0.640,
Uh-huh.
and then the upper one would be 0.85956. Anyway, if you round that up one, it would be 860.
Yes. Okay. Sweet.
That's what we got.
Yep.
Oh, good. I'm glad we're the same.
Okay, sweet. So it's the second answer.
Wait.
So if you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval? So
Huh. It went down.
yeah, yeah, because it would decrease because the larger the sample size, the more accurate the information, right?
Right.
I would assume so.
So then wouldn't the confidence interval increase? Oh wait, no, the confidence interval is just what you're doing. It's either 95, 99, or whatever. So wouldn't it just stay the same? That's a trick one.
Well, huh?
Because the
Because
95% thing stays the same no matter what else you can change x and all that kind of stuff. You can add 500, and that still is in a 95% confidence level. The only time you change the confidence level is if you actually change it to you're doing a 99% or you're doing 90%. So the confidence level would stay the same unless you change the study. Does that make sense?
okay.
Or am I just blowing hot air?
Well, I don't know, because I put in 80 instead of 60 on the inputs for the test, and the confidence interval went down.
For n, you changed n?
Yeah, for n.
Because I changed it to 500 and it's still the same, and then I put in 10 and it's still at 95%. 95 hasn't changed at all.
Are you talking about the 0.95 under the confidence level?
Yeah, yeah. That's the confidence level is 0.95. It's 95%.
Okay, because it's asking what would happen to the confidence interval.
Oh, not level. Gotcha.
Yeah. And so yeah, when you put 60 or when you put 80, it goes down.
Okay. Yeah, it does. It does. Sorry. I read that wrong. I thought it said confidence level.
No worries.
But if it did say level, I would have been right. So.
Yes, you would have.
So there we go.
So we're decreasing.
Yeah.
Increases.
Okay.
Okay, I think it's your turn, Amy.
All right. To conduct a hypothesis test for one proportion, two requirements must be met. Suppose P equals 1/2. What is the smallest N can be, and both requirements will be met?
That's where this NP stuff comes into. Just so you guys know, we can do the actual formula just to double check. But the tutor that I was with yesterday, when he was showing us that, he was saying that if it's 1/2, it will always be 20. And if it's 1/3, it'll be 30. If it's 1/4, it'll be 40. If it's 1/5, it'll be 50. 1/6, 60. 1/7, 70. 1/8, 80, and 1/9, 90. So, just so you guys know. But we can work out the problem.
I gotta write those down next time. Let's see.
So basically, whatever the bottom is, you times it by 10.
Yeah.
Oh, okay. So 1/2
Right.
is 20.
So 1/2, 2 times 10 is 20.
Mm-hmm. Yeah.
So
Because I'll show it here. One sec. So if we do, what's it? NP greater than or equal to 10. So N is, oh, we're looking for N, right?
yes.
So N times P is 1/2, so 0.5. And then you would divide that to get rid of it so that N is by itself. And 10 divided by 0.5 is 20.
Well, look at that. Okay.
So yeah, so
So the smallest it could be is 20 then. Right?
yeah. And he was explaining it because I was asking, like, well, because if you do the other formula, it might be a different answer, or I don't know how that works out. Sometimes you'll get a different answer, and
Yeah,
so
both of them, because
yeah,
sometimes they'll satisfy one, but it won't satisfy the other.
right,
So like for the next one, we know that 1/10 is 100, right? If we're timesing it by 10.
let me
Right.
double.
And then we want to do the other formula just to make sure. So it'd be what was N again?
What?
We're
Well,
solving for N.
oh, we're solving for N. Duh. Okay. So, okay, this is where we have to do the algebra part to get N.
Yep.
N. So 1 minus P equals 10. So we do the 1 minus P, which is let's see. So P, 0 or 0.1. And we have so 0.1.
So just so you guys know, there's gonna be some other problems where it won't be as easy, where it just has 1 over something. It might have like 4 over something or 3 over something. When that happens, I would just suggest just stick to the formula because I don't know how that easy trick stuff works, and I don't want to confuse you guys.
Right.
So as long as it's 1/2 or 1 over something, then yeah, that's always the answer. Is the bottom denominator times 10, or the denominator times 10.
So this one, n would have to be 100, right, for number 10?
Yeah.
Yeah.
Okay.
Ha ha ha. Can't trick us now.
All right, who's up?
I'll go.
Okay.
For questions 11 through 16, use the following information. For the water quality study and the reading, about 60% of the macro invertebrate water quality indicators have historically been associated with good health. The researchers suspect that water quality in the area has decreased. They conduct a hypothesis test using significance level alpha equals 0.05 with the following hypotheses. They collect new data, and this time n equals 80 and x equals 38 indicate good health. The conditions for conducting a hypothesis test are satisfied. So once again, it's the whole P stuff. So what's P?
So P would be 0.6.
Oh, duh.
Yeah.
Ha. Big old letters, and I didn't even see them. Okay, so pick 0.6 times 80. That's over 10. And then 1 minus 0.6 times 80 is 32. So yeah, it does satisfy it.
Cool.
Okie doke.
Great. Okay, so what is P hat?
Cool. So then we just do the 38 over 80, right? And that gives you p hat.
Yep.
Yeah.
And I got 0.475.
That's what I got. Tara says she's not feeling good.
Uh-oh.
Okay. So now we need to find the tested statistic, so the z-score. Let's see. Okay. So this is where we do that, let's see here. Is it the p hat minus p over the standard deviation?
Yep.
Okay.
Yeah.
So, okay, so we got p hat, which is that point 475. So, oh, all right, parentheses. There we go. 0.475 minus, and p was 0.6, right?
Yep.
0.6. And then we're gonna divide that by the square root. Oops, wrong button. Oops. There we go. Let's see. So then we do p, which is 0.6 times 1 minus p, which is 0.6. Where is that? And then we're doing that over n, right?
Yep.
Over, and then the sample size was 80.
Yes.
Yep.
All right, so I got the z is negative 2.282 and a bunch of other stuff.
Yep.
That's what I got.
Same here.
I'm so glad he showed me how to use the calculator. Hey.
That makes Such a difference.
I know.
Okay, so negative 2.282.
Yeah, goodbye.
So then 14.
So now we
That's
are we 14?
applet, right?
Yep, applet.
Oh, gotta find that now.
And since the alternative is saying that it's less than 0.6, then that means we have to shade on the left. Just the left.
Um, where is it?
Okay, so I got 0.0112.
Yep, same.
Yeah, I'm still trying to find my bookmark for that. I'll just go with what you guys said. What's it? It was point what?
0.011. Since we're rounding to 3 decimals.
Okay. I got that one with the weird green line on it. The one that has the Irish flag or whatever.
Oh, the student whatever.
Yeah. Now where's the actual probability?
All right, so the decision.
Oh, so what is the decision for this test? So if the P is low, reject the null. It's definitely lower, so.
Great. Last one, guys.
Wow, that was fast.
No.
We know what we're talking about now.
Which of the following best summarizes the conclusion of this test? There is sufficient evidence to conclude that water quality in the area has decreased. Insufficient evidence. Okay. So
This
we
one always
rejected
gets to
it.
me.
So that means it had to so if the null was that it's the same and we reject it, then that means it's not the same. So where's the actual question that we're doing again? So yeah, it's so we have the let's see, the null is p equals 0.06 or 0.6. And the alternative is that p is less than 0.6, so it would be a decrease.
So then there is sufficient evidence to conclude that water quality in the area has decreased?
Yes.
When is it ever insufficient evidence? Because I feel like every now and then they'll throw in that one.
There's insufficient evidence.
That's when the P is high.
Oh, when it's higher than the
That's what I'm thinking is when then you have insufficient evidence because your null was proved to be correct.
Okay, what happened? So wait, guys, so 3 is actually wrong. So it's asking for the population proportion, which is just P. So that is the population statistic thing. That's right. Last night because I kept making the same mistake and I should have caught that. Yeah, P hat is the sample proportion. So,
that's
yeah, I have that written down.
So yeah, go ahead and change that before you submit it. But everything else is right.
So it is sufficient evidence to conclude that water quality in the area has decreased?
Yeah, everything else is right but that one. Then but 3. So I just change it to P, and then you should be good to go.
Oh man, you volunteered as tribute. Thank you.
No problem. So, yeah, I was thinking that when you said that, I was like, wait, isn't it the other way? But
there's too many things to remember. P,
yeah, there are.
P hat, S, T, Z.
Z star, P star.
Too much.
Yeah.
And pretty much as soon as December comes, it's going to be gone from my brain.
I have the same feeling that mine will be gone before I take my next test. So.
Well, yeah, that's a possibility too.
That's funny.
All right.
Well, you guys have a good weekend. Wait, about the group thing. So we need to get a study approved by this Saturday. Is that what we need to do?
Yeah, just the study one, just the designing the project. That's the only thing that needs to be done. So as we speak,
the driving questionnaire. You know, who's a better driver?
I think that's a great one.
Who's a better driver?
Men or women? That would be a funny one. It would be a fun one.
It would be a fun one. I agree with that.
Okay.
And so, like, I guess our null hypothesis could be that they're the same, that men and women are equal drivers. And then the alternative could be that they're not equal. And then based off the information we get from the survey, we can find out what people think.
Okay, I sent you two an email on your Gmail for the Google Doc, so it's already been put on. So.
Cool. So then, are you gonna turn that into Brother Baldwin saying what our study is, or?
Sure. Yeah.
Okay.
Is this when we need to each sign up for the part that we're gonna take?
Yeah. Yep. And it's all in here.
Okay.
It's all in the Google Doc. You just
cool.
type in your name, and then so.
Thanks for doing that, David.
No problem. Okay, so we're gonna test who's a better driver, male or female, men or women.
Yeah, that would be fun.
Okay.
Yeah, I think that's a great one.
Sounds good.
He'll approve it.
Because I could definitely see a lot of people wanting to answer those questions when you walk up to them. Hey, we just want to ask you.
Well, and you could even, like, on social media, you could do, like, SurveyMonkey and put it out there and have
That's true, yeah, we could get our Facebook friends to vote,
friends
too.
on Facebook to do it.
And then we'll get like, should we? Okay, yeah, I guess we'll figure it out all that later, but sounds good.
Okay. Cool beans, guys.
All right.
Okay, sweet.
So,
thanks so much.
Week for the same times, right?
What's that?
Next week, Wednesday and Thursday?
Yeah.
Sure.
The following week we'll probably have to adjust because that's Thanksgiving.
Yeah, that's...
Oh, yeah. I say we all knock it out on Wednesday. Just kidding. Wednesday we don't have school, but... Okay, sounds good. We'll see you guys next week.
Have a good weekend.
Have a good one. Bye.